This is page 3 of your notes. Hopefully you checked your answers on pages 1 and 2 before you decided that you were ready to do page 3. Now you're going to solve quadratic linear systems, which is the same idea, but algebraically. Do you know what algebraically means? Lots of work. It means that you can't just type it into Desmos and write the answer down this time. On your quiz, you have to do one of these problems. There's only one, but it's half of the points on your quiz. So if you can't at least get most of this problem right, you're not passing your quiz. So please take this seriously. Step 1, you need to set both equations equal to each other to have only one variable left to solve in the equation. So in this first system right here, we're going to take these two equations, these two functions, we're going to set them equal to each other. I'm going to write x squared minus x plus 2 first. Equals 2x, because that's what the other one is equal to. Step 2, get your new quadratic equation into standard form. Remember, that's ax squared plus bx plus c, and it needs to be equal to 0. So the only thing that we need to do in this equation that we've written for ourselves is subtract this 2x. It matches up with this minus x, so that's where I'm going to put it. I'm going to rewrite that x squared, or this is negative 1 minus 2, so negative 3x plus 2 equals 0 now. Step 3, since it is quadratic, you must factor the equation to find the possible values of x. If you would rather use the quadratic formula, I'm going to write that here. You can, or quadratic formula if you want. But I'm going to factor because I think that factoring is easier. I think that that's faster, so that's just what I'm going to choose to do. So step 3, remember you have to write the a value is 1, b is negative 3, c is 2, and then I'm going to type my x times y and x plus y into Desmos to get my numbers. X times y is 2, x plus y is supposed to be negative 3. Those two numbers are going to come out to be negative 1 and negative 2. Remember, you have to take that a value and you have to put it underneath here in a fraction. It's not going to change our problem at all this time, but sometimes it will. All I'm doing is rewriting to show you that those over 1s don't matter in this case. And then we have to use the zero product property to split our two parts and set them equal to 0. Since x minus 1 equals 0 and x minus 2 equals 0, that means that x equals 1 and x equals 2 are our possible values of x. But when you solve a system, are your answers just x values? No. After finding the x values of the intersections, you must plug them back into one of the equations to find the matching y values. It doesn't matter which one you plug these into. You can plug these two x values in whichever function you want. Why would you pick the first one though when you can pick the second one? That just doesn't even make sense. So step 4, over here I'm going to write, is that 2 times 1 gives me 2, and then 2 times my second value is 2 is 4. So my first point of intersection is 1, comma 2, My second point of intersection is 2, 4. Step 5, check solutions with the graph. So you're going to check your solutions on Desmos to make sure that they work. If I come over here to check your problem and it's not right and you haven't checked it on Desmos, you know that's going to be the first thing that I tell you to do. So you might as well do it before I get there anyway. Assuming these are right, because you're going to check them on Desmos, those are our 2 solutions. I want you to go ahead and try number 2 at least on your own. I'm not going to come and help you until you try it, so you might as well start it. If you think you're fine, you just keep working after that.